All right, let's move on to step part 2. Part 2 starts here. Right, in part 2, we will use Squill to check the IDS alerts and gather more information about the series of events related to this attack. Let's open up Squill and put our ID in, analyst, CyberOps. Okay. Start Squill. Can I move? Okay. Locate the group of alerts from January 27, 2017. So this is happening at 2020, so I need to go up to find the 2017. Right, so this is 2017. We have January here. According to Squill, what are the timestamp for the first and last of the alerts that occurred within about a minute, actually, not a second, within a minute of each other. So this is going to be 54. This is the hour, this is the minute, so 54, the 54th minute. And we go until the 55th minute. So here is the end. So within 1 minute, from minute 54 to minute 55. So these are the alerts that happen. Maybe I should. It's okay. All right. So this one is within a minute. Investigate the alert in Squill. Click the show packet data and show rules. So we want to see what's the content of the alert and the content of the data itself. Okay. Okay, select alert 5.2, ID 5.2. According to the IDS signature rule, which malware family triggered this alert? So we want to see the content of this part, the rule. Maybe I just, can I move this a bit? No. So the malware family that caused this alert is actually this guy, sudo dark leech. So the family is actually, let's change to red, sudo dark leech. Right, maximize the Squill window size, the event message column, so that you can see the text of the entire message. All right, so look at the event message for each of the alert ID related to this attack. Okay, it's going to be a bit challenging here. I'm gonna close down this bit. Oh, okay. Wrong button. All right. So according to the event messages in Squill, what exploit kit is involved in this attack? So we need to scroll down to see the kits that the Squill managed to attribute this attack to, that has been used in this attack. So okay, so the exploit that was deduced by this Squill is actually exploit kit RIG. So it is right, so beyond labeling the attack as Trojan activity, what other information is provided regarding the type and name of the malware involved? Okay. So we have here Trojan activity. Let's move some more. Here we see still classified as Trojan activity. Let's move some more. Trojan activity. Trojan activity. Trojan activity. What do we see here? Okay. Right, for this alert ID 575, we see that it's also classified as ransomware server check-in. Okay, ransomware server. So let's jot that down. Right, by your best estimate, looking at the alert so far, what is the basic vector of this attack? So thus far, what we have seen is it all started with the user visiting the web page. So the attack vector is actually the web page that was compromised. Compromised web page. And this can also be considered as malicious web page actually. All right, let's move on to the next step. We want to view transcript of event, so let's look at event ID 52, 5.2, sorry, not 52. We want to see the transcript. Okay. So what are the referrer and host websites that are involved in the first SRC event? Okay. Right, so it is coming from Bing.com, so it's clear that the user has entered a search in Bing.com looking for home improvement and remodeling your kitchen. So that's those were the keywords that was entered into Bing search engine, and from there the search engine probably has given a number of websites, so one of them being homeimprovement.com. So the user probably has clicked on that homeimprovement.com. All right. So we want to look at alert 5.24, and we want to see the transcript. Okay. So refer to the transcript and answer the following question. What kind of request was involved in this transcript? So we see there is a GET request here. So GET request. And it's actually using HTTP 1.1. So 1.1. Were any files requested? So we see here the file that was requested is a JavaScript file. So DLE_JS.js. So this goes here. What is the URL for the referrer and the host website? So the referrer is Home Improvement. Home Improvement. And the host website is actually retrotip. .vision urbana.com.ve. How the content encoded? So the encoding was using gzip here. So again, this is compressed file. So malicious code normally get hidden by the way of passing it through compression. Okay, close the current transcript window. In the school window, right-click alert 5.25. So let's close this one. Look at 5.25 and open to the open the transcript. All right. According to the information in the transcript, answer the following questions. Okay. How many requests and responses were involved in this alert? So we see this is the first request, a GET request, and the first request and the first response, and the second request was a POST, and then the response. Then we scroll some more. There we have the third request, another GET request, and we got a response from that GET request. So there are in total 3 requests and 3 responses. 3 requests and 3 responses. What was the first request? The first request was a GET request. So let's go back to the top. So the first request was a GET. Let me write it down better. GET CT equal Vivaldi, etc. Who was the referrer for this guy? The referrer was Home Improvement. Who was the host server to the request? tyubandme.com. tyubandme.com. Was the response encoded? We see here, yeah, it was encoded in gzip. Yes. What was the second request? So the second request, as I recall, is a POST. So POST request. And this code OQ equal CEH3H8. Who was the host server? Who was the host server request to? So it was requested to hold on. Okay, so it was requested to tyubandme.com. tyubandme.com. Was the response encoded? Let's see. Yes, it's still encoded in gzip. What was the third request? So let's look at the third request. This one is quite long. So the third request, we get a GET request, and BIW equals cmonkey. Who was the referrer? So we see referrer here was tyubandme. And what was the content type of this response? The content type here we see here is application Shockwave Flash. So application X shockwave flash. What were the first three characters of the data in response? So the first three characters are the last DST here, are these three characters here. So we see it is CWS. Alright, so CWS is basically a file signature. File signature help identify the type of file that is represented. Different types of data. So go to the following website. So let's click on this Wikipedia. That will tell us the list of file signature, and we're going to find what is the signature for this CWS. So we want to find CWS. So CWS is flash, right? It's flash, and the extension is .swf. So this is Macromedia Flash. Sorry, not Macromedia. Adobe Flash. So it is SWF Adobe Flash. Okay, close the transcript, right click on the same ID again, choose Network Miner. So same ID, 525. Go to Network Miner. So we have Network Miner, this one is 525. Yes, we are looking at 525 here. Network Miner. Okay. Okay, so open up Network Miner. So we're going to look at the files type, files tab. So here we have three files that was transferred over that communication. So, okay, let's look at the question. How many files are there and what types of files? So there are three files here. Three files. And the types are HTML, HTMLs, and SWF. All right. That concludes part 2.